Please title these notes Graphs for Notes, Relative Extrema, and Inflection Points, and write today's date. By the end of this lesson, you should be able to find relative minima, relative maxima, and inflection points for f of x from graphs of f prime of x or f double prime of x. So the first thing is that you really need to have memorized the chart from previous times. So we can just do the basic form of the chart. So f double prime, f prime, and f. See if you can fill this in faster than I do. Plus minus 0, plus minus 0, plus minus 0, increasing, decreasing, extrema, increasing, decreasing, extrema, concave up, concave down, inflection points. So, what we're doing today, sometimes we don't need the whole graph sketched. Sometimes we just want to find the x values where a function has particular characteristics. So let's give an example. Actually, let's give ourselves lots of room. Let's write the function f of x has a derivative f prime of x that is graphed below. Find all values of x where, then there are going to be several parts of this problem. So first, let's go ahead and sketch this graph over here. This is f prime of x. So we'll start at -3. We're going to have a little relative maximum at x equals -2, a 0 at x equals -1, and an inflection point, a relative minimum right there, another inflection point at x equals 1, maximum at x equals 2, another inflection point at x equals 3, and then end right there. So let's find all values of x where f of x has a relative maximum. Now, one of the key things to realize is that this is asking for f of x. This is f prime of x. So we can't just say, oh look, right here, oh, let's label these -3, -2, -1, 1, 2, 3, 4. We can't just look right here and say, oh, there's a relative maximum, that's our answer. This is f prime of x, and this is f of x. So we have to use the little translation chart that we just drew out above. And the first thing we're going to do is use our problem to write our answer line, the line we're going to read our answer off of. And in this case, we're interested in f of x. So my answer line is going to be an f of x line. And interested in relative maximum, that's extrema, that's the increasing, decreasing line. Now we're going to use what we're given to do a translation line. Basically, we're going to need to translate our answer line into what we're given, look about what we're given, and then go back and translate that back to our answer. So my second line is going to be based on what I'm given. This is the given line. And in this case, we're given f prime of x. And so now the key part here is to translate this. I know that for my answer line, I want f to be increasing, decreasing. I have f prime given, so that means I'm going to translate that into the positive negative line for f prime of x. Now, I can tell positives and negatives in f prime. So starting here at -3, actually these should not be arrows, they should be numbers. So from -3 to -1, f prime is positive. From -1 to 2, f prime is negative, and from 2 to 4, f prime is also negative. Once I have that, I can translate this back the other way, shrink, into f. So positive translates into increasing, negative translates into decreasing, negative translates into decreasing. And then I can go and label these. I can see increasing to decreasing, that's a maximum, and then this is nothing. So, looking right here, where does f of x have a relative maximum? At x equals -1, right here, because, and then we're just going to describe our reasoning. It turns out on the AP test, these little sign charts are not actually sufficient work shown to give you credit. You have to actually write out the statement. F prime of x changes from positive to negative. So f of x changes from increasing to decreasing. Let's come up here to this nice space we left next to the table, and let's summarize the steps. One, draw and label. The answer line. This is the line that's based on the problem. Right down here, it's the line you're going to read your answer from. Identify if you're given a graph of f, f prime, or f double prime. Draw and label. Label the translation line. Fill in the translation line. From the graph. Translate to the answer line. And then answer the question. Okay, let's look at another example problem. find all values of x, we're going to use the same graph where f of x has an inflection point. So we start off by drawing our answer line. We're interested in f of x having an inflection point. Inflection point occurs on the concave up, concave down line. We're given f prime of x. So our translation line, or our given line, whatever you want to call it, is f prime. And we know that to translate from concave up, concave down in f to f prime, that's increasing, decreasing. Now, going back up to our little graph of f prime here, we can now fill this in. Oops, I did it again. It should be -3 to 4 and -3 to 4. So it's increasing until -2, then decreasing all the way to 0, then increasing to 2, then decreasing again to 4. Now I'm going to translate increasing to concave up, concave up, concave down, concave up, concave down. So f of x has an inflection point at each of these places. Concavity changes. X equals -2, x equals 0, x equals 2, because f prime of x changes direction. That's increasing and decreasing, that's direction. So f of x changes concavity. We can also use two lines at a time. So we're looking for what values of f of x make f of x concave up and decreasing. Okay, so once again for our answer line, we've got f of x, concave up, concave down, but we also want this one. We're interested in both. And as we saw before, we have f prime of x, so that means concave up, concave down translates to increasing, decreasing. Increasing, decreasing translates to positive, negative. And now, just like normal, I'm going to fill that in just like we would any other three-line chart. So from -3, increasing to -2, decreasing to 0, increasing to 2, decreasing to 4, positive from -3 to -1, negative until 2, negative after that. So now let's go ahead and do our little translations. Increasing to concave up, decreasing to 0, decreasing becomes concave down, right like that. And then from -3 to -1, positive, negative. Positive becomes increasing, negative becomes decreasing. So notice how I lined these up. So the 2's are right on top of each other. The -1 is between the -2 and the 0. That's really going to come in handy for this next piece, because what we're looking for is we're looking for where f of x is concave up. So concave up occurs right here and right here. Concave up and decreasing. So decreasing occurs right here. So what we want to do is we want to find the overlap. Ooh, concave up. Whoops, 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 my bad. I totally shaded concave down. Concave up is right here. Concave up is right here. Decreasing is right there. So here is where we have the overlap between concave up and decreasing. So starting at 0 and ending at 2. F of x is concave up and decreasing when x is between 0 and 2. There's a debate about whether or not the endpoints should be included. The AP test permits either with the equal sign or without. There's kind of a case to be made that that the endpoints shouldn't be included, so I generally don't, but either way is fine. Because f prime of x is translation, increasing, and translation negative. Okay, so that's our first problem. Let's do a similar thing with a graph of f double prime. Here's our second problem. The second derivative of g of x is graphed right here, so that's g double prime of x. For what values of x, A, does g of x have an inflection point? So our answer line inflection point is concave up, concave down. And what we're given for our translation line so we have g double prime. So that means we're translating from here, skip over all the way to here. So concave up, concave down translates to plus minus. So let's fill in the plus minus line. These do generally have arrows this time. -2 to 1 to 3. There we go. So now we're translating 2 across, so plus becomes concave up, negative becomes concave down. There we go. Now notice, we only have inflection points when g of x changes concavity. So there's an inflection point here and there's an inflection point here, but there is no inflection point at x equals -2. So x equals 1, x equals 3, because g double prime of x changes sign. So g of x changes concavity. And for part B, for what values of x is g of x concave down? Well, we can just look at the chart right up here. We've already done the answer chart and the translation chart. G of x is concave down when x is between 1 and 3 because g double prime of x is negative. Okay, let's do some more problems like this. The graph of f prime of x is given below. For what values of x? A is f of x increasing. Incidentally, you also sometimes see this as has a positive slope. They mean the same thing. But the key thing here is that we are interested in f of x, where it is increasing and decreasing. We have f prime of x. That translation is plus minus. So positive to negative 6, negative to negative 2, positive to 2, negative, oops, I'm going to run out of room for the rest of the time. There's a little 6 right there, and there's another little negative after that. So, translating that, that means up until negative 6, increasing, followed by decreasing to negative 2, increasing to 2, decreasing to 6, decreasing to 6. F of x is increasing. When x is less than negative 6, x is between negative 2 and 2, because f prime of x is positive. As I put each of these next ones up, pause the video and try to do them on your own, and then come back and I'll show you the answer. For what values of x does f of x have a local maximum? This is exactly the same thing as a relative maximum. You'll see both vocabulary words used. Okay, go ahead, pause the video, give that one a shot. Okay, local maximum. So we know that f of x, we're going to have the increasing decreasing line. We are given f prime. So that's going to be the positive negative line. Positive to negative 6, negative to negative 2, positive to 2, negative to 6, and negative after that. It's the same line that we drew out up here. I just drew it out bigger so we could actually see a little better. There's a local maximum here, and right here. Because f prime of x changes from positive to negative. So f of x changes from increasing to decreasing. Okay, next, for what values of x does f of x have an inflection point? Try that one on your own. Come back when you're ready. Okay, we're interested in f of x. x inflection point is concave up, concave down. So when we translate that into f prime of x, concave up, concave down translates into increasing, decreasing. So we go back and look right up here, decreasing until x equals -4, increasing until -1, decreasing with a little sort of pause at 1 where it flattens out until 4, increasing until 6, and then decreasing after that. So it should look like that. Notice at 1 there's a decreasing and another decreasing. So decreasing translates into concave down until -4, concave up to -1, concave down to 1, concave down to 4, concave up to 6, concave down. There we go. So where there are inflection points, f of x has inflection points at x equals -4, switch, x equals -1, switch, no switch in concavity right here, x equals 4, there's a switch, x equals 6, there's a switch, because f prime of x changes direction. So f of x changes concavity. Okay, last letter for this problem. For what values of x is f of x concave down with a negative slope? Remember, negative slope, going down like that, that's the same thing as decreasing. Okay, go ahead and try that one. Okay, so in the wonderful world of f of x, we know we're going to need the concave line. Actually, I'm going to give me some more room here. And decreasing. Now notice we've already done these up here, so there's no need to go through the whole entire cycle again. We just have to transfer them. So f of x is going to be concave down until -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. There we go. Just transferring that from this line down to this line. Now I'm going to transfer from this line down to this line. So up until -6, it's increasing. Then it's decreasing all the way until -2. Then increasing up until 2. Then decreasing to 6. Then decreasing after that. So that's what this looks like. Notice that I've lined up the numbers, so -2 is between -4 and -1, and so on and so forth. So now we're looking for concave down. With a negative slope, so decreasing. Now we're looking for where these overlap. So here, there's a concave down and decreasing piece. Here, there's a concave down and decreasing piece, and then here as well. So these numbers, this was -6 to -4, this was 2 to 4, and this was 6 to infinity. So f of x is concave down and decreasing, negative slope. When x is between negative 6 and negative 4, between 2 and 4, or when x is greater than 6, because f prime of x is, let's see, concave down translates into decreasing, and decreasing translates into negative. Here's our final problem. After you write it down, pause the video and try it on your own, and then I'll show you how it goes. Okay, so what's different about this one is notice there are no numbers here. It's just saying how many inflection points. So we can still do our same thing, it's just we don't have a particular number for these. So the thing is that if it helps, we can just label these. So let's call that A, let's call that B, C, D, E. If you picked out other important characteristics like maxima, minima, that kind of thing, you can just give them their own letters too. The reason that I picked that out, I'm actually getting a little bit ahead of myself. I know that I'm interested in f of x, inflection points, concave up, concave down. I'm given f double prime, and I know that the translation from concavity for f to f double prime is positive negative. So I know that I'm only really interested in these zeros, the places where the curve crosses the axis. So I know that up to A, let's just call it A, f double prime of x is negative, then it's positive to B, then it's positive again until C, then it's negative until D, then it's negative again until E, and then positive after that. So when I translate this, concave down, concave up, concave up, concave down, concave down, concave up. Remember, inflection points only happen when concavity changes. So f of x has inflection points. Actually, it's not even asking for where the letters are, it's asking for how many. So I see there's one change right here, no change, one change right here, no change, one change. Has 3 inflection points because f prime of x changes sign 3 times. So f of x changes concavity 3 times. That concludes these notes.